Welcome dear students to the EDUHUNT IIT and Neet Foundation classes. In this particular class, we are going to learn an important formula to calculate the formal charge. Formal charge is a charge that is going to be developed on an atom in the formation of a covalent molecule. So in this particular class, we are going to know what is the formal charge exactly and how to calculate the formal charge present on a particular atom in a molecule we are going to learn in this particular class. Okay, are you ready? Okay, let us start now. So in chemical bonding topic, we are moving further, and in this particular video class we are going to learn the formal charge present on an atom in the covalent molecule. So dear students, first let us try to understand what is formal charge. Formal charge is an arbitrary charge that is going to be developed on an atom during the formation of a covalent molecule. Actually, it is a hypothetical value. It is an imaginary charge, imaginary value that is going to be developed on the atom in the molecule formation. Okay. So, the formal charge is the arbitrary charge that is going to be developed. Okay. Then, what exactly is the definition of formal charge and what is the formula to calculate formal charge? Let us observe. Formal charge definition says that the arbitrary charge that is developed on a molecule in the covalent molecule formation, a particular molecule formation. That means every atom has got certain number of valence electrons. Suppose for example sake, if you take nitrogen, has got 5 valence electrons. Oxygen, because it is a 6th group element, it has got 6 valence electrons. Got it? You know, these are the valence electrons. So in the formation of a molecule, these particular atoms might gain electrons, might lose electrons, or these two things may not happen also. They might not be losing electrons, or it might not be gaining electrons. These three things might happen. Understood? So when these three phenomena are taking place, automatically some kind of charge is going to be developed on that atom, that we call it as the formal charge. Simple, right? So formal charge definition, simply keep it in mind that it is an arbitrary hypothetical charge developed on the atom during the formation of a covalent molecule. Simple. Clear? Now come to the formula to calculate the formal charge. Okay, the formal charge calculation is very easy and the formula is very simple. Formal charge is equal to V minus L minus half into B. This is the formula to calculate the formal charge. I will explain you what are V, L and B. Okay. So simply what is the formula? V minus L minus half into B is the formula to calculate formal charge. Then immediately you will ask me, sir, what is V, what is L and what is B? Simple. V is equal to number of valence electrons of an atom. Number of valence electrons of an atom, right? And L is L for lone pairs, lone pair of electrons. Okay, L is number of electrons in lone pairs around that atom, in lone pairs. Okay, in that atom, if there are any number of lone pairs are there, those electrons we need to consider in this area of L. Okay. Next, B is equal to number of electrons in bond pairs. Number of electrons in bond pairs. So now you got what are V, L and B. V for the number of valence electrons possessed by that atom, simple. L for the number of electrons in lone pairs. Please do remember, we are not counting the number of lone pairs. We are counting the number of electrons present in lone pairs. Okay. And what is B? The B for number of electrons present in bond pairs. B for bond pairs. So total number of electrons present in bond pairs we need to consider. Simple. So hope you have got the idea of this particular formula. What is formal charge? Formal charge is equal to V minus L minus half into B. Simple. And what is V, what is L, what is B? I have given those three things also. Just keep it in mind. Now we are going to apply this formula in the calculation. For that purpose, we are considering a simple molecule, ozone molecule, which is written in the Lewis dot format. Okay, let's start. Okay, please observe, dear students, ozone formula is what? O3. You all know. Okay, and these three oxygen atoms are linked to each other in this pattern. O, double bond O, single bond O, and there are three lone pairs on this oxygen and a lone pair on this particular oxygen. Okay, so this is how the Lewis dot structure of O3 molecule we have to write. Okay, in the previous classes I have explained you the way to write the Lewis dot structures. Please practice that one so you can easily write for any given molecule or ion. Okay, so anyhow I have taken the Lewis dot structure for the O3 molecule. Okay, now these three oxygen atoms formal charges we are going to calculate by using the formula that what we have already learnt. Okay, so for that purpose these three oxygen atoms we are specifying certain numbers in order to avoid confusion. Okay, see, I am saying this first oxygen, this as the first oxygen. Okay, this is the first oxygen, and say this is the second oxygen, say this is the third oxygen. So we have given the numberings to these three oxygen atoms. Now we are going to calculate the formal charge of these three oxygen atoms, right? So first of all let us write the formula. Formal charge is equal to V minus L minus half into B. Okay, this is our formula now. So now let us calculate the formal charge of this particular oxygen. Okay, see how much simple this is. See, formal charge of oxygen 1. First oxygen's formal charge we are going to write now, calculate now. This is equal to, see dear students, first of all in the place of V we need to have a value. This is the oxygen atom. Oxygen in its valency has got 6 electrons. Oxygen atomic number is how much? 8. You know this thing. And how we place the electrons? In the first shell oxygen has got 2 electrons, and in the second shell oxygen has got 6 electrons. Second shell is the valency shell for oxygen. You know this point, outer shell. So outer shell has got 6 electrons. So we will take the valence electrons of oxygen as 6. So in the place of L we are substituting 6. Sorry, in the place of V minus. In the place of L, what we have to take? We have to take the number of electrons in lone pairs. Okay. So in the case of the first oxygen, valence electrons we have taken. How many those are? 6. And in the place of L, we have to write the total number of electrons in the lone pairs. See dear students, this oxygen has got 2 lone pairs. Okay. This is a pair of electrons, this is a pair. So a pair has generally 2 electrons. Since there are 2 lone pairs, total how many electrons are there in lone pairs? 4. So in the place of L, we should substitute 4. So 6 minus 4 minus half into B. B for number of electrons in bond pairs. So totally there are 2 bonds with which this oxygen is attached. Yes or no? This oxygen is linked with 2 bonds, or it is having 2 bonds. Understood? So since there are 2 bonds, each bond will have 2 electrons. So 2 2s are 4 electrons are there in the bond pairs. Simple. So in the place of B, I am substituting 4. So our substitution is over. Now let us calculate. So this 2 cuts this 4 2 times. So automatically it becomes 6 minus 4 minus 2, which is nothing but 6 minus 6. How much? 0. Got it? So there is no charge developed on this particular oxygen in this covalent molecule formation. So the first oxygen's formal charge is how much? 0. Please do remember this thing. The first oxygen's formal charge value is 0. Hope you are able to understand this one. Right? Now let us consider the second oxygen's formal charge calculation. Let us do this. I am doing here formal charge of oxygen 2 is equal to, right, same procedure. This oxygen's valency has got how many electrons? 6. Any oxygen atom in its valency will have 6 electrons. So that is fixed value in this calculation. So minus how many electrons are there in lone pairs around this oxygen? Please observe, all of you. This oxygen has got one lone pair, right? Lone pair consists of 2 electrons. One lone pair, 2 electrons. So the number of electrons in lone pairs are how many? 2. Right? Next, we have to substitute the number of electrons in bond pairs in this formula. You know this. Minus half into number of electrons in bond pairs. 1, 2, 3. 3 bonds. Right? How many bonds are there around this oxygen? Please observe. Okay. 1, 2, 3 bonds. Each bond has got 2 electrons. So 3 2s are 6. So number of electrons present in bond pairs around this second oxygen atom are 6. So 6 minus 2 into half into 6. Clear? So please observe, this is 6 minus 2 into half into 6 now. This 2 cuts this 6 3 times. So it becomes 6 minus 2 minus 3. Right? So which is nothing but 6 minus 5. 6 minus 5 is how much? 1. And that 1 is having the positive sign. Right? That means plus 1. How much charge it is having? Formal charge plus 1. So the first oxygen atom's formal charge is 0, whereas for the second oxygen's formal charge we have got the value plus 1. So the formal charge of first oxygen is a big 0. For the second oxygen we have got plus 1. Right? Finally, we will move to the third oxygen atom's formal charge value, which now you can do on your own. Yes or no? You can do this now. Very simple. Recollect the formula. Formal charge is equal to V minus L minus half into B. Substitute the electrons present around these oxygen atoms. Okay? Automatically you will be having the formal charge of this third oxygen. Okay? Anyhow, I am calculating this one also. Up to this point it is okay, no? So in order to calculate the formal charge of this third oxygen atom, see, formal charge of oxygen 3. Formal charge of oxygen 3 is equal to, I am writing the formula. So V minus L minus half into B is equal to, please observe, oxygen atom, number of valence electrons are 6. Within fraction of seconds you can calculate it now. Okay, number of electrons in lone pairs. Once again, please observe this carefully. There are 3 lone pairs around this oxygen. 1, 2, 3. 3 lone pairs. Each lone pair has got 2 electrons. So 3 2s are 6 electrons are there in lone pairs around this third oxygen atom. Okay, so 6 minus 6 minus half into number of electrons in bond pairs. This oxygen has got only one bond. It is attached with only one bond pair. Understood? So since it is one bond, it has got 2 electrons in its bond pair. Understood? So in the place of B, we should substitute 2. Okay, now calculate this. 2 cuts this 2 one time. So this becomes 6 minus 1. Means what? 6 minus 6 these 2 are minus, no? 6 minus 7, that is equal to minus 1. So the formal charge developed on the third oxygen is how much? Minus 1. So please observe, dear students, all of you, these 3 oxygens formal charges we have calculated. The first oxygen has got 0 formal charge. For the second oxygen, the formal charge is plus 1, and for the third oxygen, the formal charge is minus 1. So the 3 different oxygen atoms in this particular ozone molecule have developed hypothetically or arbitrarily these charges, which we call it as the formal charges developed on the atoms of the particular molecule. Right? Is it easy or not? Very, very easy. You can apply this to any given Lewis dot structure in the form of a molecule or in the form of an ion. Okay, please do remember the formula. Okay, understand the terms in that formula and simply observe or write the Lewis dot structure, calculate according to the formula. Automatically you are going to have the formal charges of the given of the atoms in the given molecules. This is very simple. Okay, and this is at the same time important also. You will be finding its applications in theoretical examinations as well as in entrances also. Hope all are able to understand this way to calculate the formal charges. Okay, please practice this. In our worksheets also I will explain you later on. Okay, so we will meet again with another concept in the next video. Until then, thank you so much.